Okay, I'm just going to review some factoring of polynomials before we start our limit unit because it is definitely a skill that we want to be very good at. If I look at here, one of the most important things to remember is that no matter what, you always look to take out a GCF. We have 6 problems on this page, and the first thing I notice in this one is that a 2 and an n could be divided out of each of those terms. I say divided out, however you might say factor out. And if I have 18m squared over n divided by 2n, I would be left with a 9m squared. And if I divide this one out right here, I'm left with a minus n squared. If I look here at this one, I look and I think I could divide a 2 into each one. I'm going to write divide 2 into each one for people who may need that. And I'm left with w squared plus 10w plus 25. Down here, if I look at these two at the bottom, I will notice when I look at both of those that I could divide a 3 into each. They are both actually the same problem. I'm just going to show you a couple ways to do those. I'm going to divide a 3 into each one. When I do that, I'll get a 3. 30 divided by 3 is 10. Negative 27 divided by 3 is negative 9. 6 divided by 3 is 2. Same thing here. I'll just recopy it. It is the same problem. So on the front 6, all I did so far was take out GCFs because I always do that first. I'm going to actually flip it over and look at this problem back here. A number that goes into both 64 and 1,000 is 8. If I divide an 8 into each of those, I would get 8y cubed minus 125. So now I have worked with taking the GCF out. Now I'm going to look at each problem individually. My first two here are what we call difference, which means it has to be a minus sign, of squares, or difference of perfect squares. First one right here, x squared is a perfect square because x times x is x squared. 64 is also a perfect square because 8 times 8 is 64. If you remember from Algebra 1, this would factor into an x to start because x times x is x squared. But now I need numbers that multiplied together give you negative 64, which would be a negative 8 and a positive 8. If you multiply this back out, you will get that. If you were thinking, well, 8 and 8 is not the only way, well, it's the only way to make sure that there are no x's in the middle. Hopefully you remember that if you multiply these together, you get 8x. And here you get negative 8x. That's why there are no plain x's in the middle. Over here, again, I want to bring the GCF down. And then this again is a difference, and these are perfect squares. They are perfect squares because 3m times 3m is 9m squared. And n times n is n squared, but I need it to be negative, so I'll make 1 minus n and 1 plus n. Next group is trinomials, where the lead coefficient is 1. That means the number in front of the x squared is a 1. When that happens, you simply want to think what numbers multiply together give you the last one, but combine or add together to give you the middle number. Numbers that multiply together to give you negative 42, but add to give you negative 1 are negative 7 and positive 6. Negative 7 times 6 is negative 42, but negative 7 plus 6 is the negative 1. Now you're going to look at this one here. And originally the number in front of the w squared was not a 1, but now it is. So now I can think what numbers multiplied together give you 25, but add to give you 10. And those numbers are 5 and 5. So it's a 2, and then it's w plus 5 and w plus 5. Since they are exactly the same, and only because they're exactly the same, you can rewrite it as w plus 5 the quantity squared. Okay, moving to the next group, which I think is the hardest group. We're going to actually do this problem 3 different ways. First way we're going to do is guess and check. So we already took out our GCF of 3, and we cannot do what we did up here because our lead coefficient right here in front of our x squared is not a 1. So bring down my GCF. I'm just going to guess what goes first and second based on a few things. First, what numbers multiplied together give you 10x squared? Well, you have some choices. I think I'm going to choose a 5x and a 2x. You could choose 10x and 1x. I hope I chose one that worked. But 5x times 2x definitely gives me the 10x squared. Then I look here at the end and I need to choose numbers that multiply together, give me 2, keeping in mind my middle term needs to be a -9. So I think I'm going to try -2 and -1. Now, you must check what the middle term, if the middle term works. And you check that by multiplying these 2, which is -5x, and these 2, which is -4x, and then adding them together. -5x and -4x definitely gives me the -9x, so I got lucky. What I guessed worked. If it didn't, I'd have to switch numbers, try other options until I got it to work. Now, over here, I would like to use a method called slide and divide. I know some of you liked this one last year, so I want to make sure you'd be okay with it. When the lead coefficient is not 1, what you can do is simply slide it over and multiply it by the last one. So I'm going to bring that 3 down, the GCF, but then I'm going to slide that 10 over. It's no longer there, and write x squared minus 9x, and 10 times 2 is 20. Now it looks like a problem we've had before. What numbers multiplied together give you 20, but add to give you -9? Again, I'll bring down the 3, and those numbers are -4 and -5. So this method is called slide. I did that. It's also called and divide. Whatever number you slid over, which in our case was a 10, I must divide by that. And then you'll have fractions that need to be reduced. 4/10 is the same as 2/5. 5/10 is the same as 1/2. Once the fraction is reduced, if it comes out pretty, great, but these still would be fractions. The number in the denominator you just put right in front of the x, so it's 3, then 5x minus 2. Now I'm going to take that 2 and shove it in front of the x, 2x minus 1. So we get the same answer, it just depends on which one that you like better. All right, last method to do that exact same problem I have on a separate sheet of paper. It's called grouping. You might have done this last year. So here is the original problem where I took out the 3. So now you're going to do it this way. 10 times 2 is 20. You write it up here and you think, what numbers multiplied together give you 20, but add to give you -9? And the numbers are -4x and -5x. So I keep everything else the same, but I just split the middle term into those two numbers. And it does not matter which one is first and which one is second. Then you look at the first two and you think, what can I take out of those? Or what can I divide evenly into both? Well, I can divide a 2x into both. And these two, I could divide a -1 into both. Because if this is a negative, I usually try to take a -1 out because I really can't think of anything else that can go in there. So I now have a 3 still, and I took out a 2x. When I take out that 2x, I'm left with 5x minus 2. Here, I factor out a -1. And when I do that, I'm left with 5x minus 2. With this method, you actually know when you did it right because what's in parentheses should be the same. So you still have the 3, what was in parentheses I pull out first. And if I take that out of both, what's left? A 2x minus a 1, which is the same thing as we had on the other two. I do have a few students that learn that method and really like that one. That's totally up to you on what you want to do. Okay, and now let's go to the back side. The back side we have when there are 4 terms. When there are 4 terms, you want to take out of something from the first two. Looks like I can take an a squared out of both of those. And what can I take out of both of these? It looks like I could divide a 5. So I'll put the a squared in front and I write what's left. And then I'll take a 5 out of both of those and I'll write what's left. I'm hoping what's left is the exact same thing. So if I divide an a squared into both of those, I'll get a 2a. If I divide an a squared into both of those, I'll get a minus b. If I divide a 5 into there, I get 2a. If I divide a 5 into there, I'll get a minus b. These are the same. 2a minus b, I'll pull that out. And what am I left with? A squared plus 5. Not sure if you remember that one, but that is factoring by grouping when there's 4 terms already. Okay, last but not least is sum or difference of cubes. Cubes are numbers that you can find the cube root of. For example, the cube root of 1 is 1, because 1 times 1 times 1 is 1. Cube root of 8 is 2, because 2 times 2 times 2 is 8. Cube root of 27 is 3, and so forth. Unlike difference of squares, we actually have a sum or difference for cubes. So if you have cubes such as 8 and 125, you also know if the exponent is divisible by 3, it's a perfect cube. It will work whether there's a plus sign or a minus sign. The pattern is this. Cube root that number. Cube root of 8x cubed is 2x. Because 2x times 2x times 2x is 8x cubed. Cube root that number, which is positive 5. Then, to get these 3 terms, you square the first one. 2x times 2x is 4x squared. Multiply, change the sign. 5 times 2x is 10x. Change the sign to negative 10x. And then square the last one. 5 times 5 is 25. That's the pattern to factor a sum or a difference. So now let's go to this one. Here, same idea, but it's a difference. And this one had a GCF, so again, just bring the GCF along. It will create a binomial, 2 thingies, and a trinomial, 3 thingies, or 3 terms. Cube root of this, 2y. Cube root of negative 125 is negative 5, because negative 5 times negative 5 times negative 5 gives you negative 125. Over here, square the first. 2y squared is 4y squared. Multiply, change the sign. Negative 5 times 2 is negative 10y. Change the sign, make it positive 10y. Square negative 5. Whether you square a negative or a positive, your answer will always be positive on the end. You may have learned this last year. This is the fancy way of writing it. I like to say cube root, square it. Multiply, change the sign, and then square the last one. I hope that helps.